for joining the Citrus Educational Conference as part of the 2021 Virtual Southeast Regional Fruit and Vegetable Conference. I'm Lindy Savell. I serve as the president of the Georgia Citrus Association, and I will be the moderator for this presentation. I'd also like to thank SQM for sponsoring the 2021 Citrus Educational Conference. And let's watch this short video provided by SQM. Pesticide CEU and CCA credits are available for most presentations offered during the live Southeast Regional Conference. Check the Pesticide CEU Guide for a list of approved presentations and participating states. The Pesticide CEU Guide is located in the Event Resources tab under the Media Player. The guide is also available at the Resources Center, located on the main menu of the conference platform. Please note, pesticide credits will only be available for registered attendees and only during the live conference. Credits will not be available for on-demand viewing. The pesticide CEU process is a simple three-step process to receive pesticide CEU and CCA credits. First, go to the audience chat box located on the left side of your screen and type your first name, last name, and the states for which you are requesting credits. Again, go to the audience chat box located on the left side of your screen and type your first name, last name, and the states for which you are requesting credits. You will need to do this for every presentation to request CEU credits. The second step is to sign out at the end of every presentation. So to sign out, go to the audience chat box, type your first name, last name, and the states for which you are requesting credits. You will be reminded to sign out at the end of the presentation. The third step is to complete the pesticide CEU registration. You only have to complete this registration one time during the conference. This is not required with every presentation. To access the pesticide CEU registration web link, open the pesticide CEU guide on the Event Resources tab located under the Media Player. The Pesticide CEU registration web link is located on the front cover of the guide. This presentation is pre-recorded to reduce technical difficulties. We will be answering your questions live at the end of the presentation. You can submit a question at any point during this presentation by typing your question in the questions box and pressing send. Don't forget to thank our 2021 conference sponsors and exhibitors for visiting the virtual trade show and featured products pavilion. Thank you. Lastly, don't forget to join us each morning for coffee chats and each evening for networking. Be sure to check the conference agenda for details. And now I'd like to introduce you to Brian Shade. Brian is a Senior Product Manager, the East Region for Netafim. He has 33 years experience in agriculture and 30 of those years in low volume ag irrigation. His presentation is about cold protection. He has spoken for us before, and his presentations are very relevant and interesting. And Brian, I'd like to turn it over to you at this point. Thank you very much.
Thank you, Lindy, and thank everyone for coming today. As Lindy said, I'm the Senior Product Manager for Netafim USA based in East Tennessee. Used to be a citrus grower down in South Florida back in the early days, went through the 88, 89 freezes as a grower, and then moved over to the irrigation supply side of the business and was involved with frost and freeze protection on thousands of acres actually in the Southeast, all the way up into the Carolinas on a variety of crops, citrus being one, blueberries, strawberries, things like that. So we're going to talk a little bit about that today, and hopefully give you some things to think about when you're planning your systems or when you're operating your systems. And please feel free to ask any questions as we go along, and Lindy and I will try to do our best at the end to reach every one of you. So first thing, we're going to discuss our agenda. We want to talk about what is frost. The other things are going to be about the practices to protect against frost protection using sprinklers, which is actually my specialty and what my company does and several others. Factors to consider while you're choosing your frost protection system, and the do's and don'ts, the actual how-tos of operating, installing, and using a system to best protect your crop. So first of all, what is frost? It's a coating of ice that's going to form in humid air, cold conditions. This morning here in Tennessee, when I was recording this, we were 28 degrees with 95% humidity, and we've got enough frost that you'd have to scrape your windows before you got in your vehicles to drive away. So that's typically when they're going to form. Now, the challenge with frost is at certain times of the year, it can damage the tissues of the plant. It could be the cell walls is typically what we're dealing with of a bud or even the flower, and we want to protect against that damage. And we can do that with a couple of different methods that we're going to discuss in this presentation. So the frost types that we typically deal with here in the States are the advection frost, which is a windborne freeze. This is what we dealt with in '89 down in South Florida. It was a very high wind event, very cold. And it's an air mass that moves into the area, bringing those freezing temperatures. And typically there's really no known solution when you have these high wind events. It's just, it's not economically feasible. We did in '89 run our irrigation systems. The way the grove was set up, we had ample amounts of water. We were also able to flood ahead of time and build up a lot of ground heat. And we had a oversized irrigation system so that we could apply enough water. Can't honestly say whether it benefited us that night or not, but I know on the second night when we had the radiant frost, it absolutely did help us. So that's the one we're typically trying to protect against. These are those cool, calm nights when it just drops. So our springtime radiation frosts, that's when our winds are very low to no winds at all. We have clear skies and the temperature's just, 32 and below. It's cold days, clear days, and we just have an ability at that point to turn on an irrigation system that's sized properly, set up properly, and powered properly. And the reason I say powered properly, in a lot of the areas that we typically grow, we're on electric. And agriculture, a lot of times, is the first ones to get turned off in the events of high demands. You know, they're going to take care of the houses first, then they're going to take care of agriculture where it's available. So if you are on an electrical system, on a grid, and you're using electric pumps to drive your system, I would suggest that you look at backup generators or even a PTO drive for your pumps, if that's even possible. So the damage to the trees during the frost conditions are the physical processes that happen during the frost, and that's the dehydration effect. So during the frost, the ice is formed on the outside cells of the plant, and it causes a water loss and dehydration. So we get cell breakage. The morning oxidation, now it's going from freezing to evaporating. So we've got oxidation of plant cells from the sun's radiation, and that causes even more damage. So our critical temperatures at which the plants receive damage, and most of our citrus that I'm aware of, we've got a threshold of 27 degrees. So if we can keep things above that, then we typically won't see damage in our plant material. Now, some other crops that you may be growing, that temperature may change a little bit. I would reach out to my extension services on those specific items. So a lot of things that can affect this is the stage of growth. One of the things we used to experience in Florida, we have nice warm temperatures. We'd have a nice rain, and ahead of that cold front, we'd get a flush, and then the cold would come in behind it and burn all the flush off. So the stage of growth is very important. Where you are in your fruit set, the dormancy, if you're growing one of those crops, it's going to go dormant, where we are in that stage. Plant water content, if we've been experiencing a lot of dry weather and we're stressing our plants, we've got to be very aware of that. And of course, as with everything in what we do, our overall plant health is going to help us condition these plants to withstand the cold event, pests, and everything else that attacks us as growers. So the next item we're going to talk about is the practices that are typically used in the U.S. and in other parts of the world for frost and freeze protection. And the common practices that we typically see are heaters. You guys, some of us older folks will probably remember the smudge pots up on the ridge. We've advanced from that to oil-fired fans and things like that. Just big fans to keep that still air moving so it doesn't just settle in those low spots. Thermal nets have become very popular in some areas with certain crops where we just cover it and prevent that frost from settling. And then, of course, water application. So here's some of the fans. And what they do is they're going to pull in cold air and warm it up and reprocess it. That's the unit on the left. The one in the center actually just takes that cold air and blows it back up into the sky. So we're trying to push it up, 150, 200 feet to just prevent that settling again. We want to stop that settling of that cold air. Then we have our big fans, windmills, things like that are just going to keep that air from settling again. We don't want it to settle. In the last grove that I managed, we had an area behind a cypress head, and we thought it was better protected than other parts of the grove that were more exposed to that wind that was coming in. And actually it was 15 degrees in South Florida in that cold head. So if we'd had something back there to stir it up a little bit, I think we could have been more in line with our temperatures out in the front part of the grove. Here's the thermal nets. And I know this isn't very practical for a larger operation. You also have to deal with storage of these things afterwards. But in a lot of your high dollar crops, these things can be very, very effective. And then we get into the water and the water application. And this really, it is rocket science in a way. We have to talk about thermals and BTUs and water application rates and misting and not misting. and making sure that water source is available and on well before the temperatures go to freezing and stays on after those temperatures come back up. And we'll talk about that later in the presentation. So this screen might be a little bit hard to see where you're at, but this is about the advantages and the disadvantages of the different types of the methods. And we can share this with you to visualize at home if you feel like you need to. If you'll notice on the lower line, I've got an area boxed out, and that's where we're talking about an inadequate precipitation rate. And this is the most critical thing that you guys need to think about. And when you're talking with your irrigation designer, we need a specific precipitation rate. We have to apply enough water that's going to freeze and provide us a nice clear sheet of ice. If we don't apply the right amount of water, we're doing more damage. If we apply too much, we're also going to do damage because we're going to break the trees. This is what happened to the citrus operations in Florida on the Ridge in the 70s and 80s and 90s with the big Rainbird impact sprinklers that were up over top of the trees. They applied so much water that the trees actually broke. They split. The trunk split all the way to the ground in some places, and the trees were destroyed. We are not going to do that with a low volume irrigation system. We're going to sacrifice part of that tree. And I promise you it will come back. When we experienced the freeze in '89, we came in a few days after the freeze. We pruned back all the dead wood. We sprayed it with a nutrient package. And when those trees flushed again, it looked like lollipops out in the field. So we had this nice trunk and then this amazing foliage, and that you couldn't tell the trees 6 months later had experienced any damage at all. So that's because we had the right amount of water and we were able to run it early, long, all night long. So the main advantages of frost protection by water is we can target specific areas. Again, going back to the large impacts that cover the entire grove. We just don't want to waste that water. We don't want to apply that much water and risk damaging the trees. The ease of operation. Most of you guys are probably experienced with low volume irrigation already. We're not talking about anything new here. It's just making sure it's the right size and applied properly. So the capital expense is lower because it's not a separate system from what you're already doing. It's something you're currently using to grow those trees. The lower operating expense, again, we're using it all the time, all through the year. We're using it to irrigate. We're using it to fertilize. We might even be using it to apply certain herbicides and pesticides through the irrigation system. And it's, of course, suitable for multiple applications. So again, at the bottom of this slide, it mentions commonly accepted precipitation rates. Those are localized right there at the tree, depending on the crop and depending on where you are somewhere between 0.1 and 0.2 inches per hour. I typically will shoot for that 0.2 in most areas of the Southeast. There are some crops I'll go into the lower numbers, typically it's strawberries. But when it comes to citrus, I like to shoot for that 0.2. So the next item up is the actual how-tos on frost protection of the sprinklers by using sprinklers. And we're going to talk about the over canopy and the physical processes. So what's happening here when we apply water, naturally it's warmer than our air temp, right? So we're getting a transfer. There's 144 BTUs that are going to be exchanged when we start putting out water. As it cools down, it's going to transfer that energy to the air around it and also the tissue. And that's what we're looking for. The latent heat, this is that 144 BTUs that's given off when that water changes state. This is when it goes from a liquid to a solid. So it's going to, again, give off even more heat. And this is what we're looking for. And then it creates an ice barrier. So going back to what I said earlier about clear ice, we want clear ice. And in some of these pictures, if you go back and look through them and you look at the icicles that are hanging, they're not frosty. It's not like the ice that comes out of your freezer for your cold drinks. We want clear ice. This is 32 degrees. It's not going to get any colder. The tissues under it are protected, and it's going to stay there. Where frosty ice is actually colder. And I know that doesn't make a lot of sense, but it does. So you want a nice, clear, solid layer of ice. That'll keep that tissue underneath it at 32 degrees. And we want to keep that water running again until the sun starts to come up in the morning. If you look at this slide, you can see the icicles that are hanging just to the left of that sprinkler. And this is a targeted sprinkler. It is actually just watering a strip. You put this on something grown on trellises. But if you can see those icicles well enough, you'll see that that's basically clear ice. It's almost like glass. And that's the goal. That's what we're looking for. So things that we're going to need to consider. This is when you're sitting with your designer or you're asking a consultant, what do I need to think about? So the distance between the trees and the diameter of the trees, of course, the treetop diameter during your frost season. Again, this applies to multiple crops. The size of the area I want to protect. And again, we don't want to try and save it all. You'll risk more damage than good by trying to save that entire tree. So I would recommend with our sprinkler selections, you have your spaghetti tube long enough that you can raise that up into the canopy of the tree, just above the crotch, maybe just a little bit higher, and you're saving those inner scaffold branches, and that's about it. Your water availability. You need to think about what time do I have to start this system, how many gallons am I going to pump, and what time can I turn it off? Our situations that I lived through, we ran about 12 hours. We started our pumps. We had 11 pumping stations on the last grove that I managed. There was 3 of us starting pumps. You have to start them early enough to get everything up to pressure. All the valves are open, check the fields. We typically started at 40 degrees. In my presentation, I'm going to talk about a minimum of 37. And the reason we talk about those temperatures is because there will be a temperature drop when that water first starts going into the air. So we might be at 40, but if you've got a good temperature sensing device and you first turn on those sprinklers, you're going to see that temperature drop 4, 6, 8 degrees. We have to put enough water out to recover and come back up before our air temperatures start falling below 32 constantly. So the energy availability goes back to what I was talking about with having a diesel backup, PTO drive, something that's going to make sure when you start that pump, it does not turn off during the night. The site topography, again, those low spots or what we feel like are protected areas, which in my case in 89, what I thought was a protected area actually was my worst area because it did stop that air movement back there. So those microclimates need to be considered. The meteorological properties of the site, where are you located, what are you going to experience there, and the expected duration of that frost event. So the full coverage plan, and what this portion of the presentation is going to talk about is the 3 methods. So the full coverage and a targeted and a limited area. Full coverage would be those sprinklers that are going to cover all the trees, all the drive middles, everything out there that's within range of that sprinkler. So in this case, we're using a almost 2 gallon per minute large head is what it actually is. On a almost 40 by 40 spacing at 36 PSI, it's got a 0.1 precipitation rate. its flow rate per acre is 55 gallons. So you can take that number and say, okay, I've got this many acres, I've got to have this much water supply. Then you get into the strip sprinklers, the ones that are just going to water that band. And this goes into a lot of the apples, certain fruits that are trellised, vineyards and things like that. They're good down to about 22 degrees. It's going to be a little bit higher application rate, but it's going to save you about 30% of your water compared to that full coverage option that I just showed. And of course, it's going to run at a little bit lower pressure. Then we get into the localized option. And this is the sprinkler that's focused on a tree. That's all we're trying to cover. Just one single tree. We're not trying to do a strip. We're not trying to cover everything in between. Every tree has its own sprinkler. In this case, we've got a 10 by 13 spacing. Our tree tops are about 10 feet. So we figure our square feet up, and we can do the math on a precipitation rate. In this particular case, it was a 7 gallon per hour sprinkler because of the spacing. And our precipitation rate was 0.15 inches per hour. So this is actually our higher precipitation rate, but our gallon per minute per acre is the lowest. It's 39 gallons per minute per acre. So it allows us to take a limited water supply and actually be more effective in a limited area. So that high efficiency targeted option, total flow, 35, 36 gallons. This is also a 10 by 13. This was a little bit lower sprinkler flow rate. So it just wants to show you that we can actually get into a better place if we have to, if we have a limited supply. And you can see that let me go back to that real quick. You can see that the sprinklers were actually raised up above. In this case, it doesn't show the whole tree just for graphic purposes, but they got up above some of those lower scaffold branches, and then they're taking care of that portion of the tree. So this one, I used an apple orchard in this summary. So our local application versus full, we're 27% less water. That strip versus the targeted, I'm actually dropping it another 10%. So again, when you've got a limited water supply, and you guys cover a broad area. Some of you are on wells, some of you are on surface water, some's creek, some's river, and it's changing throughout the season, especially in those colder times of the year where we're not getting as much rain. Having that lower demand may work to your benefit. Another reason that could help you is when it comes to the system design. So pipe, pump, emission devices, valves, all of that kind of stuff, filters, everything has to be sized for those higher flows. So if I'm dropping my flow almost 50%, and actually doing as good or better of a job, then that's a win for you. So the do's and the don'ts. Some of these we've already covered, but they're important to reiterate. And we're going to touch on those again briefly and then move on. So, of course, we want to have the system installed before the frost season. Kind of makes sense, right? We want to make sure it operates properly. We want to run that system. I usually start a few days before. We want to make sure every single emission device was working at its full flow rate. We want to make sure that the pumps the oil's changed, the fuel tanks are full, whatever may occur there, and make sure that all the valves work, everything's ready to go. We want to open the system on time. We want to make sure we start it before we get below 37 degrees. Every second counts. On our first night, we did not start early enough, and we actually ran out of time, and some of our pumps did not run because by the time we tried to start them, the lines had frozen out in the field. We have to keep our water supply continuous. We don't want to delegate this to someone else. We want to make sure we're on site. We're going to be there. We're going to call it. We're going to tell it when to start, and we're going to be able to communicate with small radios, cell phones, whatever it takes. And don't shut the system down too early. We want to make sure that the temperatures are starting to rise And as that ice starts to melt, that we don't create that very first thing that we talked about when it's going to irradiation. So that's the end of my presentation. I hope it wasn't too quick. I know we're a little limited on time, but I want to thank you again. And Lindy, I'll pass it over to you and we'll answer some questions.